Hello everybody. Today I would like to make a new screencast. This screencast I will try to give a very short overview about monolithic architecture versus microservice architectures. So monolithic architectures means is a really large applications. Large application means is all the business logics, all the business logic are all the in a set of in a specific database. I mean all the backend is only one database. So that means it's nowadays the monolithic application to maintain or to extend in the upcoming technologies or upcoming complexities of the web applications is absolutely hard. That's why the concept is coming, the microservices architecture. That means, so in shortly, microservice support to break the boundaries of large applications means monolithic architecture or monolithic applications. What the microservice did, it's logically, you can say logically independent, smaller integrated systems. That means if you have a really big applications, let's say one example like eBay or Amazon, or even though in the YouTube or Facebooks, there's a set of interaction, a set of logical interactions, like you need to register something. You have to be, as like eBay, you have a buyer, you have a seller, and you have the payment informations, and you have the documentation informations, and you have also the communication, I mean the mailings and the conversation between the buyer and seller, even though the service provider, the eBay, those functionalities is independent, is logically independent, and those functionality has to be handled as a microservice way, microservice architecture way. So that means if you have a web applications, then you divide your business logic as like RESTful API or microservice architecture, microservices, and then you also divide your backend server, like here backend server with the logical one. So if you look these diagrams, like we have a monolithic applications, the web frontend, and the business layer and data access tier and layers, and the backend server. This is maybe this database has 200 or 400 tables is interrelated. That one is absolutely hard to maintain, and even though it's absolutely hard to maintain these databases. If you in the right side, you see the microservice architecture. So all still there's a web applications, and then we divide here the user registration part, and it has a microservice like RESTful APIs, and it's its own independent database, DB database. And then there is the web service, the web application has a service center API or microservice, and that is its own independent service center database, and R1 development as a microservice, and then you have own independent R1 development backend, and you have a billing and payment modules or APIs, and it has own backend data server. So, and then plus and plus, you can do whatever you would like to do. So maybe you have maybe the documentations, or you have the communication on polymeril, and you can add it microservice. So this microservice is really flexible to control, or to develop, or to configure, or partition it. It's like, let's say you have one web application with this 4 microservice. You have a 4 web application. So one web application did the registration part, one web application did the service center, service centers service providing and consuming part, and also the one application for urban development control or management part, and one application for the payment and billing part. So it's possible to make 4 web applications, and these are the application is independently can deploy it or configure, and is possible to maintain. If you think about the monolithic one, it's absolutely hard to maintain those type of applications. Applications. That's why this nowadays is a monolithic application is a really important part for the developers to think about it and to implement based on the monolithic architecture, or then because of monolithic architecture you cannot do many things with the architectural pattern. But microservice architecture, you can do all the flexibility, and you can modify it, and you can move forward to in the future what's the upcoming technologies based on that architectures. So here is my web applications, and then you can see here then. So with this screenshot, I would like to introduce. I would like to do my microservice registration and discovery and monitoring by using the Eureka admin server. And the next screenshot I will try to do with by using Spring Boot admin server. So let's see here, if you see the diagram. So I have a Eureka admin server, and this is the server try to register our client applications. We have 3 client applications, like user registration applications and service center applications, and then urban development applications. So that means the Eureka server will maintain our registration, and server also discover our client applications and monitor the client applications. The monitor means what goes on. These all the client applications is a server okay, a server is okay, is server is up, is server is down, what's the interactions, what's the health condition of each of the client applications, what's the metrics information, what's the info, or what's the logging informations. I mean, what's the in general, what's the actuator, the endpoint information for each of the client applications. It's possible to monitor those informations, or those information by Eureka admin server. So nowadays is a lot of microservice we need to integrate, or need to call, or we need to layer it for building the more dynamic web pages or dynamic web applications. That's why I try to give you one screenshot about that one. How can we register our microservices, and how can we do our discovery, our microservices, and how can we monitor those microservices by using the Eureka server. So let's start. So then let's start. First we need the Eureka server applications. and this is the server. We try to register our client applications. So, and you see, you can see the user registration RESTful API or microservice API. So the user registration microservices is already into my YouTube channels. You have to close look on these channels in this video, and how we did the user registration API, the developments and configuration and deployment and testing steps. Please close look on this YouTube video. And then we need to make then we should go to our second microservice applications. It is a service center application, even though this application is also available in YouTube channels. Go there and cross check the developments and configuration, deployment and testing process for this application. And then finally, urban development microservice applications, it is also available in the YouTube channel, and you please go there and overcheck all the respective steps for developments and configuration and deployment and testing steps. So if you see, we use SQL database and non-SQL database. So our user registration microservice application are using a Cassandra non-SQL database, and then service center microservice application are using GameFire NoSQL database. But in the urban development microservice application using Postgres SQL database. So let's have a start to generate those Spring Boot applications projects. So even though you can build a project via or to use the IntelliJ IDE or any Eclipse IDE, or for me, I use STS tools for Spring Boot tool suites, and then I found it is really flexible tools, and is up to date, and you can very quickly build your projects and integrate your projects or import your project into your respective IDE. So let's have a start to generate the 4 projects. So here is the Spring IO Spring project initializer. So you can select it as a Maven based projects or Gradle based projects, and you can select the languages, which language you are, and you can use the versions of Spring Boot. So then put it your group name, soft group, and then put it your project name, like Spring Cloud Eureka Server applications, and put it here exactly like your artifact ID, and then names, and then the description a little bit, and select so the deployment by packaging will be the Java-based packaging. You can select here from your Java versions, so the Java version. You can search or inject your dependencies by a search. You can say development, dev, and DevOps tools. We need the actuator. We need an actuator, and we need. So even though you can go to the selection bar. So for server Eureka Server application, we don't need to select any databases, because this is a server. So you need a Eureka Server discovery, and this is the most important one, and we already selected the actuator, and that's all. So then sort of versions and generate the projects, and project generation is done. So now we need our all three client applications. So Spring see, we call like it Cassandra, Spring Log these applications, and you can put it your artifact ID, and even though you can full versions. For this case, we need a REST dependencies, and also the Cassandra databases, and actuator is there. We don't need to this one. We need a Eureka discovery. So this is the discovery. So let's generate the projects. So the project is done, our Cassandra based, and then we had to generate our second client application for GameFire RESTful VS. Just put it your same artifact name, and then we have to delete, and we need to GameFire database, and that's all. You have to generate projects. So our GameFire based client application is done. Now we need to generate the Spring Boot post with SQL RESTful VS. Then put it to your the same name as the artifactory name, and then we don't need to do the GameFire. You need a PostgreSQL, even though you can put a JPA, and that's all. So what we did here, so we did our 3 client applications, and then our Eureka Server applications. Then the big difference here, that your database selections, that the database dependency selections, and all the client application, you need Eureka discovery dependency injections. For the server application, you need the Eureka Server dependency injections. And now our all project is generated, and you should to get this downloaded this zip file and unzipped it in your local systems, and after that you should put it your IDE and as a Maven projects. And I already imported the all projects. Here you see our Alpha development RESTful API projects. The project is there. Then we annotated it like the Eureka Server, enable Eureka client, and Eureka discovery client, and then all the respective configuration and all the implementation. But you can get it in detail in the YouTube screenshot about this development, configuration, and deployment and testing step from the YouTube screenshot. And then we have second application like Cassandra application, and the same thing is here. So we annotated it, enable Eureka client, and then enable the discovery clients, and then all the respective configuration, development implementations, and testing. You can also get it from the YouTube, the respective from the YouTube channel with the respective video. So that is our GameFire applications, and then the same thing here that we annotated. You enable Eureka client, enable and discovery client applications, and all the implementations and deployment, configuration, and testing you can get also from the YouTube channel. So here I already imported our Spring Cloud Eureka Server application. You can see here the application main class and main methods, and is annotated by enable Eureka Server. So this is the annotation, did the server activation, and also the discover the client's applications, and build the Eureka Server dashboard web applications. So here's the SRC main resource folder. You can see here our server, Eureka Server, will be started 1040 port, and this is localhost, and this is the default settings. It means this means the Eureka Server itself is a server. It doesn't open with as a client application, so it's only the server applications. This means if you set it true, means the Eureka Server itself as a client application has to be started. So here we did the project buildings. It's like the first release of our applications. You can go there and run as a Maven installation tools. I already did it because for this screencast I try to follow the DevOps culture. So you build your applications, you implement the applications, and did all the configurations and set all the properties, and then you generate your first versions of your softwares or your applications, and then you copy your jar files into your local directory, and run the jar applications, and then the application should be running with this port number. So even though you can put it your application in jar file to the installation department, the installation department has to be installed this application into the client machines, or any of the environments, or production environment, or development environment, or release environments, or whatever it is. And that's so because here I follow the DevOps culture. That's why I try to give it to you some overview how can we do the DevOps culture, to practice the DevOps culture. So here you can see I did the same thing to release my initial version of the software, the applications. I did the same thing here as it is, like to go there and then run as a Maven installation. So it's built automatically the first version of your software tools. So here is our Spring, PostgreSQL, RESTful API, VS, WS, web service versions of the jar. And here is the same things, the Cassandra applications, and it's the same thing here. So it's kind of deployed or built and deployed somewhere, and then the GameFire applications is the same thing. It's here. So now we need to go somehow to run these jar files, or to run these applications. Or even though we can put it all the jar files for the installation department, they will install these all jars applications into the customer side, or for test environment, or production environments, or whatever it is, they can put it there. So how we did it, just like our external deployment, or our DevOps deployments practice. So here is our server applications, and Eureka Server applications, and I have a small script, batch script to run the application. So if I go there, and I can see here is my Java machines, JVM, and this is the applications. Server application has to be run, and this is our deployed jar files for this application. So it has to be go in the development environment. I try to install in development environments. So you can put it here the absolute path also, just like this part only. So you can put it the absolute path if you use jar file inside this directory. So then we have the service running. So we call it I call it our set the environments, call it, and then set the Java path variables and run the jars with the respective service versions and port number and address, and this is the most important one, is the which environment you are trying to run your applications. So let's have a start to run the Eureka Server applications based on these configurations. This is Eureka Server, so you have to run a service CMD or bet. So your Eureka server is up. Then let's cross check with this Eureka server is run up. Okay, then go localhost 4040. So your Eureka server is running. There is no application to, there is no client application in the registration process. Okay, then that's all, and there's no applications. And now the Eureka server is running. We need to register our all 3 client applications. Means we should register our user registration, microservice applications, and then service center microservice application, and then urban development microservice applications. And let's have a try to do that one as a DevOps way. So I did the same thing here for the rest of applications. So you see our environmental settings and the service start service, and then our deployed the application jar files to the here. So this is Cassandra, the same thing here. So here is our environmental settings for the profiles of the Spring Boot application, and so the application server port address, and then database username, password, or even though the NoSQL database properties of the database server applications. So then there is another. So here's the game file applications, and then there's the same thing is here. So let's have a start to run our RESTful API for PostgreSQL. So these applications to register the Eureka server dashboard. So it's a game file. Cassandra, and this is the application. So we run our RESTful API PostgreSQL server. The applications means our urban development microservice applications, and then let's have a try. And this is running, and then we can cross check our dashboard. So still not, the server is not running applications. So here you see our Spring PostgreSQL server RESTful API already registered to the Eureka server. So And now we try to run the other two client application to register here. So before to run the Cassandra applications, our Cassandra RESTful microservice application, you have to be start the Cassandra database server. So please look at the YouTube, my channels and respective videos. There's a detailed information how can you run the Cassandra server and run the RESTful API based on the Cassandra database server. So we did our configurations, and then now we start our Cassandra based RESTful API application service. And then same thing, we need to start our GameFire applications, and then please cross check again the YouTube channels and the respective video to how can you start your GameFire server, and how can you how can you did the respective development and configuration and testing with there is a videos you can check, cross check there. So let's have a start to these applications service. So now we have to cross check. Yes, so you see your Cassandra application is up to is up, and this is registered already the Eureka client server. So let's have this, the GameFire is up, no, still not. Still waiting for the have to come the so you see the now is our 3 application is registered to the Eureka server, and then you can see the 3 application is running, and then you can go check what's happening the last one since these interactions. And even though you can see the health condition for the server, so server is up to date, even though you can check it independent individual client applications, and let's say the health conditions, and this is up, and then you can see also the info is nothing there, so that is okay, perfect. So let's have a stop our one of the applications and see what's the effect of these applications. CLL, clear the window and run the server. So you see the server is down for our urban development API applications, and doesn't appear anything here. So it's into the interactions. So it was here the application was running, the application was shut down, and now we try to again to run the applications. So let's have a try. Now it's getting ready, these applications. So again the server, the application is up to date, and even though you can independently check your client applications all the endpoint informations for those client applications. And then let's do some testing with so our GameFire applications, one of the application is running. We can check it from here. See Postman, how far away. If the application is running into the Eureka Server, and you can run all the respective tests. We did it here, CRUD operations, and even though we can check it other client application to did some testing or do some CRUD operation what you did in the implementation for these 3 client application surveys. So here we check it, like here is the server is up. Okay, the discovery client, as the description, you see the effect of this one. So it's Boot Cloud Eureka discovery client is there and server is up to health conditions. Is there something there? Some informations? Yes, there's nothing there. So if it's something, so there is no record into the database. So we try to put it one entries, insert one entry. So you see it here, the body, the information for these entries. Let's have a try to put it. So it's created, and then you get the informations, and now it's check it. It's like the information is there, so it's perfect. It's information there, and the IDs, yes, it's there. So we try to update one of informations of these informations, like so send to them. Okay, it's okay, it's up to dated. Let's have a checks. Okay, it's up to dated, that's true. And put is okay, is delete is working. So we try to delete the application application, the entry IDs 100. So send to them. Okay, not any found. So no content, that's true. Nothing there. And then now post again, and now get it, and then put again, and then get it here. Okay, so that's and this is the same thing you can do for the rest of the other client application for the service center, and also the user registration and urban development APIs, which is already configured to the Eureka server. So let's have a check what's the actual status for the Eureka server So here what I did, I shut down the PostGIS, our urban development API one times, and also the shut down the Spring game file application one time. So this you see the report and what happening in the last times, and then you see the application is 2 times shutdowns, and this information is there. So you see the information of which application is down and one is canceled application. So you can monitor those applications with here. So you can put it how many applications, client application you would like to monitor or discover or register with the Eureka server. So nowadays there is a microservice and microservice architecture world. So it's maybe hundreds of clients application you have to be able to monitor for your business or for your companies. Yes, that's true. Nowadays there is a complex web applications, and then we have to be maintain those complex web applications via all the services, and we should to maintain the monitoring process for the microservice applications, and that's the goal for this screenshot. So for us, you can go our channels, and you can go Google it and search the UVSoftGroup, and then you can see our YouTube channels and our GitHub informations, and there is a Facebook page, and there is a public group in the Facebook. So we go to these channels, and then you see the information, and then this I mean the last the client implementations is here. So this is the game file implementations, and here I think so this is the game no, this is the game file, sorry, this is the game file implementations, and there's the Redis implementations, and what this is the information, so Cassandra based implementations, and there's the implementation for the urban development APIs. So just look for that one and see what you need for your developments, and just write down the commands, and then and see we can share our knowledge with this way. So I will up my new screencast in here, so you can look for there's a newer one, and do something, and write down commands, and do and give a suggestion how can we improve our ideas and our knowledge, and also share with you and your development approach, or and then in the next video I will next screenshot I will make a new screencast for the other concept for microservice architecture, as like the circuit breaker the concept, and also the client side load balancing by using the ribbon, and then I would like to do one more things to the API gateways, and that's the most important, because we need something to route and filter the applications, because nowadays the applications, microservice application, has a lot of layerings, and we need to somehow to filter it, and somehow to abstract the applications calling approach. So for this case, for API gateway, I will do some demo via using the Joule concept. So just over recap what we did. We did Eureka Server applications, and then we did our 3 client applications, the user registration applications, and then urban development application and service center application. And after that we build it as a jar based packaging, and we configure it, and we deploy it to the application, and then finally we registered our application into the Eureka Server, and we monitor all the applications into the Eureka Server, and that's all. And let's see what can we do for you in the future, and just stay with us, and now is goodbye. Thanks.